Hey there, Mr. Sutton here, bringing you the Pre-Cal Honors Chapter 6 Quiz Review Solutions on Vectors and Polar Coordinates. On this example, we're trying to get a polar point onto a graph here. So the way to do this, we have a radius and an angle. We just have to look up the angle, which is 120. That tells us we're facing the 120 direction. And the r here, this 3, tells us how many steps to walk out. So if r is a positive amount, we walk forward 1, 2, 3 steps, and if r had been negative, we would walk backwards that many steps. On this problem, given this polar point that we just graphed, we want to figure out how to graph, or write rather, two equivalent points. So to do this, there's two different ways you can go about this. One is you can keep the radius exactly the same and either add or subtract 360 as many times as you want. So for example, we could do 3 comma whatever 120 plus 360 is, which would give us 3 comma 480 degrees. And we could have also subtracted 360 as many times as we wanted. So either way, you get this kind of point. The other way to get another point, an equivalent point, is to change the radius, the sign of the radius, and then add or subtract 180 to the angle. So we could write this as negative 3 comma 120 plus 180 or 120 minus 180, either of those. And this would be negative 3 comma 300 degrees. In order to turn a rectangular point like this one into a polar point, well, we're starting with an x and y, and we need to get an r and a theta out of that. So let's start by getting the radius. That's just basically going to be the Pythagorization of the x and the y that they gave us. So Pythagorean theorem here. We've got the square root of negative 1 squared plus 6 squared, which is the square root of 37, which we can't really simplify at all. All right, moving on now to the angle. We know that the tan of theta equals y over x, and we care about tan because they only gave us x and y, no radius here. So that means that the inverse tan in this situation is going to give us theta. We're going to do tan inverse of 6 over negative 1, which is to say tan inverse of negative 6. Let's do that on the calculator. So making sure we're in degrees mode for this, we end up with roughly negative 80.5 if we round off to the nearest tenth. And at this point, we need to double check to make sure that our angle and the original point they gave us are actually in the same quadrant, because there are two places on the unit circle where we have a slope of 6 over negative 1. So we have to make sure this is the right place. So the original point up here was in quadrant 2. This was negative x and positive y values. The angle that we just got, this is quadrant 4. So this angle does not match the quadrant of the original point. To make it match, we just have to add 180. Now you could go through the trouble of getting a reference angle and getting a quadrant 2 angle and all that. Adding 180 is just kind of a shortcut for that whole dance. So we've got negative 80.5 plus 180, which is going to come out to, calculator says, 99.5. So our final answer then is going to be radical 37 comma 99.5 degrees. Now just revisiting this, if this quadrant and this quadrant had matched, if the angle actually was in the quadrant where our point was physically located, then we wouldn't have had to add 180 here. For this problem, we're trying to convert polar coordinates into rectangular coordinates. We're starting with an r and a theta, and we're trying to get an x and a y out of it. So to do this, we need our formula that tells us the connections between these things. We know that x equals r times the cosine of theta. So in this situation, that means the x value is going to be 9 times the cosine of 310 degrees, which I need a calculator to find. So there we are, and just make sure you're in degrees mode for this. Rounding off to the nearest tenth, we get 5.8 out of that. So that's the x value of our rectangular coordinate. Now we need the y value. To get that, we have y equals r sine of theta. So it's kind of like x, but with sine instead of cosine, because sine tells you the y value on the unit circle, and then we're just adjusting that for this different radius. All right, so this is going to be 9 times the sine of 310, which I also need a calculator for. Now, I'm just going to be kind of lazy and grab my input from before with cosine, but I'm just going to switch cosine to sine and press enter. We get negative 6.9, and that's the y value of our point. For this problem, we are given 2 points, A and B, and we want the component form of the vector that goes from A to B. So to do this, you basically just have to subtract the x values and the y values separately, and we have to go in the order B minus A, second minus first. So we've got -9 minus -6, or plus 6 for the x values, and then we have 7 minus 4 for the y values. So we have our vector notation here with the angle brackets and the comma in here to show that we've got x versus y values. So this then ends up being -3, 3. On this problem, we're given the component form, which we actually coincidentally just found on the last problem, and we want the magnitude out of this. So the magnitude, or absolute value of a vector, you're essentially just finding the length of it with the Pythagorean theorem. So we're just going to do the square root of -3 squared plus 3 squared. That's 9 plus 9, which is 18 inside the radical. And I can split that up into 9 times 2 and square root the 9 to get me 3 radical 2. For this problem, we're going to be doing some vector algebra. First step on these is to replace these variables here with the component forms that they gave us. So we have 4 times 4 comma -2 minus 2 times -8 comma 6. Next, we have to deal with constants being multiplied by vectors. To do that, we just distribute the constants to the stuff inside the vectors. So this one, for example, we've got 16 comma -8. And over here, I'm going to keep the minus and just distribute +2 inside here. So I'm going to have minus, and now my new vector is going to be -16 comma 12. If you distributed -2 all at once, you would just need to remember to put a plus here instead of a minus. All right, next, to add or subtract vectors, we just add or subtract the x's and y's independently. So I'm going to have 16 minus -16, or plus 16, comma, -8 minus 12, which gives me 32, comma, -20. For this problem, we are dot multiplying two vectors together. To do this, we multiply the x's together and the y's together, and then we add those two products. So we're going to do 9 times -3 plus -6 times 4. So that's -27 plus -24 for a grand total of -51. On this problem, we're trying to find the coordinates of the point that is 2/3 of the way from point A to point B. To do that, we need to figure out directions to get all the way from A to B. We need to start by getting the component form for AB. So that'll be -12 minus 48, comma, -38 plus 23, or minus -23. So our component form to get all the way from A to B, we've got -60, comma, -15. Next, we're going to take our initial point, A, that's our starting point, and to that, in order to get the new point, I have to add 2/3 of this vector that I just came up with, 2/3 of the component form, 2/3 of the directions to get from A to B. The rest of this is just PEMDAS and adding vectors together. So distributing that 2/3 over there, so we have the initial point, and over here we've got 2/3 of -60, which is, let's see, -60 divided by 3 is -20, times 2 is -40. And then doing the same thing with -15. -15 over 3 is -5, times 2 is -10. Now we're just going to add these together. So we have 48 plus -40, which is just 8. And this is giving me an actual point now. Now we have -3, or 23 rather, plus -10, so that's going to be -33. So that is the point that is 2/3 of the way between A and B. And let's just do a quick double check. 8 is at least between 48 and -12. And we have -33, that's between -23 and -38. So we're at least in the right ballpark. For the next several problems, we're going to be doing some three-dimensional point and vector analysis. The strategy on all of these is going to be to basically do what we did with 2 dimensions, but to add a third coordinate for the z values. So in this situation, for example, we have the super midpoint formula, in which we're still averaging the x values and the y values together, but now we're also averaging the z values together. So in this case, we've got 19 plus negative 35 over 2 for the x's, 49 plus 23 over 2 for the y's, and negative 42 plus 50 over 2 for the z values. Going through and doing each of these, this is going to be negative 16 over 2, which is negative 8. Here we have positive 72 over 2, which is 36. And here this is going to be 8 over 2, which is positive 4. To find the distance between these 2 points in three-dimensional space, we're going to use our 3D distance formula, which, like the original distance formula, has x2 minus x1 squared plus y2 minus y1 squared. The only difference, again, is that we're just adding something for the z values. And it's the same setup, just adding another coordinate in here. So we've got, for the x's, negative 6 plus 8 squared. For the y's, we have 9 plus 3, or minus negative 3 squared. And finally, for the z's, 10 minus 3 squared. So this is going to be 4 plus 144 plus 49, which adds up to 197 when all is said and done. Square root of 197, it turns out, cannot be simplified. This is a prime number, believe it or not. For this problem, we're subtracting these vectors that have 3 coordinates in them. First, I'm going to distribute this 9 coefficient out here, though. So this will be negative 27, comma 18, comma negative 45. And we're still subtracting the second vector without any other change. Now let's go through and actually subtract things. We've got negative 27 minus negative 15, so we're adding 15. That gives us negative 12 for that first coordinate. And then we have 18 minus 5, which is 13. And then finally, negative 45 minus negative 19. So we're adding 19, which gives us, let's see here, negative 26 when all is said and done. Okay, and that's it. Nothing else to do. For this problem, we're dot multiplying. Before we go ahead and do that, though, it might make sense to distribute this 2 to one of these vectors. I'm going to use the second one here. So we have this original 1, 3, 5 vector, and over here we've got negative 6, comma 20, comma 14. Now dot multiplying, we're going to do the x's multiplied together, 1 times negative 6. To that we are adding 3 times 20, the y's multiplied together. And to that we are adding the product of the z values, 5 times 14. So this is negative 6 plus 60 plus 70, grand total of 124.